In this episode, we are tearing down a legendary Kawasaki Z900 engine. If I didn't post a video of this engine soon, someone would probably come knocking on my door to beat me up. So yeah, I was basically forced to make this TikTok video. Alright, let's look at the clutch first. It's a FCC clutch from Japan. Honestly, you could easily guess this. This FCC clutch could be said to have monopolized the clutch market in the global motorcycle industry back in the day. In the past, for domestic large displacement bikes, if you just wanted to buy their clutch plates, they wouldn't sell them. You had to buy the entire assembly. Especially these paper-based clutch friction plates. FCC knew we didn't produce them domestically. So our domestic manufacturers had no choice but to use their clutches. But fortunately, in recent years, with the rise of domestic clutch brands, such as Chongqing Clutch and Lied Clutch, in the domestic market, they finally stand on equal footing with FCC clutches. Let's take a look at the bearings. Imported TPI bearings, which are Kymco's bearings. This engine is very wide. In the animal kingdom, donkeys have the longest faces. In the motorcycle world, Kawasaki takes the prize for length. Just look at the length of this crankcase. It feels as if the screen has been stretched horizontally. Des 800, Z900, and Z1000. These three engines actually share the exact same roots. They just change the displacement. Look at the camshaft caps, there is no wear and tear. So the entire cylinder head is perfectly fine. Nowhere on the bearing caps. And nowhere on the camshaft. I guess everyone is quite interested in the material of this camshaft. After all, we've heard of Honda 650 snapping camshafts, but never heard of this thing snapping one. However, this camshaft is made of standard materials. It's not even as good as the camshaft on Kawasaki's own Ninja 400. This timing chain is a bit kinked. It needs to be replaced, but this kind of camshaft setup is understandable. After all, this bike isn't built for hardcore performance riders. The Ninja 400 can still hit the racetrack, right? Look at the valves on the cylinder head. Looking at it this way, does it look like it's burning engine oil? No matter how good the spark plugs are, they must be replaced, and also the valves and valve stem seals. Remove the cylinder head gasket. Let's check out this piston. There are marks where it hit the cylinder head. This means it suffered a spun rod bearing. Look, this area is also polished bright from the impact. Let's pull it out and check the cylinder block. This cylinder is an electroplated ceramic cylinder. Look, after tens of thousands of kilometers, there's barely any visible wear. Electroplated ceramic cylinders are extremely wear resistant, and they offer excellent heat dissipation. The only downside to this thing is that it's expensive. But it's wear resistant, has great heat dissipation, and is lightweight. Even after running about 60,000 to 70,000 kilometers. You won't see much wear at all. Even if you measure it with a cylinder bore gauge, it's the same. This is something cast iron cylinder sleeves can never achieve. Let's check the pistons. Kawasaki's high silicon cast pistons. They are quite confident in these pistons, which is why they rarely use forged ones. Look at this connecting rod, it's discolored from overheating. And it's a bit seized up. See, a normal connecting rod should swing down freely. But this one just stands straight up and won't budge. There's no doubt it suffered a spun bearing. Take a look, guys. Wherever you put it, it just stays there. And the connecting rod on this side is also ruined. This one is damaged even worse than that one. Listen to this. Out of the 4 cylinders, only one survived. This one is discolored too. So, any bike can be trashed if ridden hard enough. Though the reliability of the Z900 is actually considered quite good. Calling it one of the gold standards for large displacement naked bikes should be undisputed, right? It's great to ride, and the value for money on the used market is insanely high. I used to drool over this machine myself. It really is excellent. Plus, there are so few good naked bikes to choose from nowadays. Look at the oil pan. As expected. Look at that, it's completely filled with copper shavings. The prices for Kawasaki Z900 engine parts aren't actually too crazy. Anyway, they are cheaper than the Honda 650s. So when people ask me how to choose between these two naked bikes, I usually recommend the Z900. This is its balancer shaft. The Honda 650 doesn't have one, does it? Looking at the crankshaft journals, they can still be used, no problem. These are copper lead bearings from Dado, Japan. Looking at it this way, it's perfectly clear. One burned black, one turned yellow. One is normal. And another one burned black. 2 black, 1 yellow, and 1 normal. After asking around, I found out that as soon as the owner's butt touches the seat, the front wheel of this bike basically never touches the ground. So, there's no such thing as an unbreakable bike. It all depends on what kind of owner it meets. Look at this connecting rod bearing. The copper is exposed and scored, so the connecting rod is ruined too. Let's check this other connecting rod. For this connecting rod, let's measure it with an inside micrometer. If it's not out of round, it might still be usable. It's just that the bearing shell is shot. The bearing shell of cylinder 3 is also slightly scored. The connecting rod itself is fine. Yep, just replacing the rod bearings for this one will do. Now let's check the rod for cylinder 4. The one that was burned the blackest. This bearing shell is completely destroyed too. It's worn down almost to a thin wafer. And it has lost all its tension when fitted inside. Let's check the crankshaft. It will probably need laser cladding first. And then a nitriding treatment. Repairing it this way makes it quite durable. Anyway, it's more cost-effective than replacing it. It basically suffered scoring on 3 journals. Overall, the build quality and materials of this Z900 are better than the Honda 650. The piston material is better. Plus it features an electroplated ceramic cylinder. And it offers much better value for money. It also has a balancer shaft. So the vibration is quite minimal. This is a Kawasaki Z900 engine. Out of the 4 crank pins, 3 were scored. The crankshaft has been repaired via laser cladding and nitriding. Now, let's assemble it. For this type of split-case 4-cylinder engine, it's best to install the pistons into the cylinder block first, and then mount it down like this. This is a much faster method. If you assemble the crankshaft and connecting rods first, and close up the crankcase, and then try to slide the cylinder block over the pistons later, it becomes incredibly time-consuming. By the way, the teardown video of this machine was already released back on January 5th. And only today am I finally releasing this assembly video. Apply some M-Soil assembly grease. The viscosity of this assembly grease is pretty close to 10W80 or 10W90 engine oil. Take a look at the repaired crankshaft. It underwent laser cladding plus nitriding. This makes it much more durable. This is what the damaged crankshaft looked like before the repair. You guys can compare the two. This is a highly reliable repair method. It's way cheaper than buying a used replacement crankshaft. However, the turnaround time for this crankshaft repair is a bit long. Because running the nitriding equipment once costs a lot, they usually wait until they have gathered several, or even over a dozen crankshafts to do the nitriding batch together. That's how it stays cost-effective. Honestly, the parts prices for the Z900 are actually reasonable. For another 4-cylinder naked bike, the Honda CB650, its parts prices are significantly more expensive. Though later on, the Kawasaki SRK 600 came along as a cheaper alternative. As for these connecting rod bolts, you need to torque them to a certain initial specification first, and then torque them to a specific angle. After torquing, use a torque angle gauge. All connecting rod bolts must be torqued to the correct angle. Put the rubber seal cover back on. Similarly, all crankcase bolts must be torqued to specs as well. Install the oil strainer mesh. Install the oil pan. Flip it over and torque down the cylinder head bolts. Just earlier, when we flipped it, to prevent the cylinder head from falling off, we temporarily threaded the cylinder head bolts in. Apply engine oil for lubrication. The colors of these oils are quite interesting. See, this one is green. There are also red ones and blue ones. Install the outer clutch basket. Since you've watched up to this point, please take a second to hit the like button, everyone. Now I am installing the clutch plates. Put on the inner clutch pressure plate cover. It is a slipper clutch, so the inner pressure plate cover is locked into place smoothly. A slipper clutch feels quite light to the touch. Look, it only has 3 clutch springs. But the specific feel of this slipper clutch isn't overly light either. Apply some M-Soil assembly grease. Install the camshafts. The Z900's tuning is focused on smoothness, so its camshaft is just a conventional chilled cast iron camshaft. The material of this camshaft isn't even as premium as their own Ninja 400's camshaft, but it is completely adequate for use. The camshaft caps also need to be torqued correctly. These are torqued to 12 Newton meters. You see, these assembly videos of mine are just highlights. For instance, how to align the timing, or measuring the valve clearances. I didn't record any of that. I also didn't film tightening every single bolt. I'm just giving a general reply to everyone here, because when I posted assembly videos in the past, a lot of people would ask if a certain bolt was left untightened. Alright, assembly is complete. Let's test the cylinder compression. Compression is normal. With fuel and spark, it will 100% start up, since the owner hasn't sent me a video of the bike running yet. That's all for this episode. Thank you all for watching.